Good morning, dear students. Let us start with today's class. In previous videos, we have discussed the basics of understanding quadrilaterals like curve, types of curve, polygons, types of polygons, interior, exterior, regular, irregular, convex, concave polygons. Then what is the angle sum property of a polygon, their formulas. Now it's time to apply all those basics in exercise 3.1 questions. Okay, so let us apply those basics, those definitions, those formulas on the questions given in exercise 3.1. The very first question is, given here are some figures. You can see on whiteboard clearly the figures I have already drawn for you. We have to classify them on the basis of simple curve, simple closed curve, polygon, convex polygon and concave polygon. First of all, understand the hierarchy. If we are having any given geometrical shape as a curve, then only we can classify that as simple. Okay. If it's simple, then we can classify it as open or closed. If it is closed, then only we can classify it as simple closed curve. If it is simple closed curve and made up of line segment, then only we can call it as polygon. Clear? And if it's a polygon, then only we can say either it's a convex or a concave polygon. Do remember. So this is the hierarchy. For a curve, we know that without lifting a pencil and without ray tracing any geometrical shape, we get that's a curve. Simple, it should be not complicated, simple in the sense. Basically here, simple curve means curve only, do remember. Clear? Then curve, open or closed, that is another factor. Then simple closed curve. For simple closed curve, the curve has to be simple, means no intersection, of course. And it should be closed, means starting and end point must be same. And if your curve is simple closed curve and made up of line segments only, then we call it as polygon, and after polygon the segregation. Let's see. The first figure, yes, it is closed, no intersection, so definitely it is simple. Made up of only line segment, yes, so it is a polygon. So definitely a first figure is first simple curve, second simple closed curve, third it's a polygon also, fourth if it's a polygon, which polygon? Inward, an angle is inward, angle inward means concave polygon. Are we clear? Next, this one again, if we see simple, no intersection, so definitely it is simple. It is simple closed curve. It is made up of only line segment and it is simple closed curve, definitely it is a polygon. And all the angles, if I see, are less than 180 degree, definitely it is a convex polygon. Are we clear? Next, if we see this one, it is not a curve at all. Why? Done? But to draw the another one, we have to lift the pencil for sure. So that is why it is not a curve at all. Clear? Because this one we can draw without lifting, but this we have to lift the pencil to draw. That is why it is not the curve for sure. So if it is not curve, it will not be simple, it will not be closed, it will not be polygon and nothing else. Come to this one. Again, if you see, it is, what do you think? It is simple. It is simple or closed, whatever you feel like. What do you think? If we see, it is not simple for sure. Simple means not any intersection. It is not simple, definitely it is not closed, definitely it is not a polygon. So again, it's a curve, but not simple, not simple closed. If it is not simple closed, definitely no polygon. And if it's not polygon, it shall not be convex or another. Clear? Next, if you see this figure, it seems, of course, simple curve. It's simple because there is no intersection anywhere. Yes, it is simple close because end point is same, starting points, end and starting points are same. If this starting point, this can be the end point. Clear? But since we cannot see any line segment, it is not polygon. So it is simple curve and it is simple closed. Next, if we see sixth question, we see a line segment, but we see a curve. So definitely it is simple curve because no intersection. It is closed, so therefore it is simple closed curve. Since it is not only made up of line segment, so it is not a polygon. Clear? Next, if we see, this is again a simple curve and it is simple closed curve. But if we see clearly, it has a curve also, no line segment. So again, it is simple curve and simple closed curve, but not a polygon. Last figure. If you see clearly this one, if you observe these 2 points, if you see these 2 points, what you will call it? Definitely you will call it as a curve or not. That's a point. If you call it as a curve, that's a point. Now tell me, is it a curve for you? Curve means without retracing. If you see clearly, this is okay, fine. But one time I have to lift my pencil in once, or maybe I have to retrace it. Simple curve means without retracing or anything. If we see, so therefore it's not a simple curve, not at all. If it is not simple, it is not closed, it is not polygon. Are we clear with this? Why it is not a curve? Very, very important. Because if we see, I reach this point. 1, 2, 3, 4. I reached. From here again, I am retracing this point again and again. I am using this point again and again. Again, see, I moved along this, I reached this point. Again, I retrace this point. So I am retracing it again and again. So if retracing is there, we cannot go for it. We cannot go for it. Are we clear? It's very, very important. Next, question number 2. Question number 2 we'll see. So retracing, it cannot be, of course, what? Yes, a curve. Because we have to retrace it again and again. That is why it is not a curve. Because we have to retrace that point again and again. Question number 2. How many diagonals are there does each of the following have? Okay. I have already given you the formula to find the number of diagonals. So number of diagonals is equal to n minus 3 upon 2, first part. That is for a convex quadrilateral. That is 4 minus 3 upon 2, 4 into 1 upon 2, 2. Second part, a regular hexagon. A regular hexagon. Hexagon means 6-sided figure. So 6 minus 3 upon 2, 6 into 3 upon 2, answer is 9. Last, a triangle. Triangle means a 3-sided figure. So 3 minus 3 upon 2, that's 3 into 0 upon 2, that's 0. Are we clear? This is one method, but if we have to show it by using the geometrical method, by construction, then how? For example, this is a convex quadrilateral ABCD. We have to join its non-consecutive diagonals. So 2 diagonals, it means this and this are non-consecutive sides. So we can draw the diagonals. One diagonal. Next consecutive point is second diagonal. Are we clear about this? Any doubt in the figure? Next is regular hexagon. When we talk about hexagon regular, 1, 2, 3, 4, 5, 6. 6-sided figure, regular hexagon. Now let's see. Now let's draw the 9 particular diagonals. If I see clearly, if you observe, A to A, this and this is consecutive, I'll attach one, I'll attach second diagonal, I'll attach the third diagonal. Clear? Next, to point B, this and this are consecutive, it means for point B, we can join this diagonal, we can join this diagonal, we can join this diagonal. So already we have joined 6 diagonals we have found. Now let's move to point C. For C, this and this points are what? Consecutive, B and D. So what are non-consecutive? Definitely F, we haven't joined, and definitely A, that we haven't joined. Clear? So how many diagonals we have got? 8 diagonals. One more diagonal is left. Can you tell me which is that particular diagonal? If you see clearly, if you come to D, these two are there. So it means this and this already joined, this and this already joined. What is left? The left one is D and F. So the last diagonal is D and F. So how many diagonals do you see? 3 with orange color, 3 with blue color, 3 with oranges, 2 with green, see, 3 orange, 3 blue, 2 green and 1 red. So therefore how many diagonals? Total 9 diagonals. Total 9 diagonals. Are we clear? Any doubt? For triangles, if we see, we don't have any non-consecutive points, so therefore there is no diagonal, therefore 0 diagonals. Geometrically also proved and algebraically also proved. Clear with this? Any doubt anyone is having? How to do? Clear? Next, question number 3. Question number 3 is angle sum property of a quadrilateral that I have proved that as a theorem in the video. So you can see from there how I proved it. It is given, what about concave? So if I take, for example, this is a concave quadrilateral. Any problem with this? This is a concave quadrilateral for sure. Now same thing, we have to apply the same thing, the same rule. Question number 3 for concave. Yes, rule is same. Again 2 triangles, if you apply angle sum property, 180 will be getting 360. Yes, concave or convex quadrilateral both possess angle sum property, that is sum of all the 4 angles of convex or concave quadrilateral is 360 degree. Clear? Next, question number 4. Question number 4 is based on very important aspect, that is the sum of all interior angles that we have already done. Sum of all interior angles. Sum of all interior angles of any polygon, I have already given you the rule, is n minus 2 into 180 degree. Clear? This is what is the question. If you see in the book, question number figure is given. What they have done, 3 sides, so 180 degree, right? Now 4 sides, they have converted this figure. If you see, they have converted this figure into 2 triangles, and then they have applied angle sum property. 180 plus 180, that is 360. After that 5-sided figure, pentagon is divided into 3 triangles. So 3 triangles, 180 into 3, that is what? 180 into 3, 540. Clearly? Then 6 is divided into 3 particular 1, 2, 3, 4 triangles. 1 and 2 into 4, that is 720 degree. So that is why they are getting this answers. But if we generalize this, general rule is this. If you see what is happening, this means this is the number of triangles. Already we are having 1 triangle is done, that's not a problem. Basically, if I see, clear? So it's very important to do. Let's see the first question. What can you say about the angle sum of convex polygons with 7 sides? Okay, the first question, 7 sides. Question B, 8 sides. Question C, 10 sides. Question D, n sides. So 7 means hepta, 8 means octa, 10 means deca, and n means n-gun. So let's see. Let's apply the rule, very important. So the first rule is n is 7. Therefore 7 minus 2 into 180, that's 5 into 180. What is the answer? 5 into 180, 900. Clear? Next, n is equal to 8. 8 minus 2 into 180, that is 6 into 180, that you will be getting 1080 degree. Clear with this? Next, 10 minus 2 into 180, that is 8 into 180. If you see, you will be getting 180 into 8, 1440 degree. When we talk about n minus 2 into 180 degree, which is the general formula. Are we clear with this? Now, I want to tell you one thing, why it is happening. If we see three-sided figure, 4, 5, 6, 7, 8, 9, 10, I would love to tell you that the angle sum property of them. Just see clearly, just observe one thing. 180, 360, 540, 720, 900, 1080, and when we talk about this one, and when we talk about this, we get this. Clear? Sorry, this. Yeah, it is correct. All degrees are correct if you see clearly. Now you might be observing the difference between them. If I see, it means what I am doing, I am adding 180 plus 180 plus 180 degree 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 plus 180 degree. This is what I am doing. Why is it happening so? Anyone with the answer? Why is it happening so? Just observe why it is happening. It's nothing new. The formula which is being generated here, it is from the definition only, the number of line segments. See, with each term, one line segment is increasing. Yes or no? One side is increasing. One line segment is increasing. And what is the angle made by a line? 180 degree. Yes. Since one line is adding to each, therefore, after each 180 degree is being added. That is why it is being done here. Very, very important. And this is general rule. This we got. That is why we made n minus 2 into 180. Why this 180? Because we are adding a special line to it. And why minus 2? Because that was a general rule. If you see. Clear? Any doubt anyone is having with this concept? Now, question number 5. What is regular polygon? State the names of regular polygon of 3 sides, okay, 4 sides and 6 sides. So what is the definition of regular polygon? Everyone knows. Regular polygon means the polygon, regular polygon means polygon having same sides in length and measure of each angle is same. Correct? When we talk about length in same, we call it as equilateral, and when we talk about angles in same, we call that as equiangular. Very, very important. Clear with this? Clear? So this is the definition of regular polygon. So 3-sided figure, 3-sided regular polygon, absolutely. 3-sided is equilateral triangle because all the 3 sides are equal and each angle measure is 60 degree. Correct? Four-sided figure, absolutely answer is square. All the four sides are equal. Each angle is 90 degree. And when we talk about six-sided figure, definitely six-sided figure is hexagon. I told you to put an adjective before it, regular. Therefore, answer is regular hexagon. Are we clear with this? Question number 6. Next question. Question number 6. Find the angle, measure x in the following figures. We have to draw the figures and we have to see what is the measurement. We have to apply angle sum property. Whatever we need to apply, we'll apply. A little bit slant. This one is little bit slant, like this. So it's 50 degree. It's x. It's 120 degree, and it's 130 degree. I'll name this figure A, B, C, D. In this figure, we have to find the value of x. Simply, we have to find the fourth angle if three angles are given. So what we will apply? We have already done in class 7th also in angle sum property of a triangle. What we used to do? We used to apply the sum of all the angles. Similarly, in quadrilateral, which one? Which quadrilateral is this? Yes, in convex quadrilateral, ABCD, angle A plus angle B plus angle C plus angle D is equal to what? We already know 360 degree. See, need to remember this. We have to at least memorize till decagon. That what is the sum of all the interior angles, like triangle 180, quadrilateral 360, pentagon is 540, hexagon is 720, heptagon is 1008 and 900, and for octagon it's 1080, for decagon it's 1260, and for the what one? The decagon we are having 1440 degrees. Like this way we have to remember them. Okay? So 50 degree x 120 degree plus 130 degree is equal to 360 degree. 250 plus 50, that is 300 degrees. 360 degree. X is equal to here plus there minus. Again we are making use of linear equation in one variable. So 60 degree. Answer is 60 degree. You have to apply angle sum property. Write the rule, very important. Angle sum property of quadrilateral, or even you can write sum of all the angles of a quadrilateral is 360. Clear? B part, B figure. They are on a line, they are on a single line, correct? It's absolutely 90 degree. Again, if I name it A, B, C, D, again I am getting a quadrilateral. This is X, this is 70 degree, this is 60 degree. Observe this question. Now, you might be thinking, sir, only two angles are given and we have to find this angle. So, at least to find the fourth angle, we must know three angles. Yes. But if you clearly see, we have been given some hint, right? This is 90 degrees. So, what would be this? This is also 90 degree. Can you tell me why? Absolutely, linear pair. If I am saying this is angle 1, this is angle 2. So, for angle D, angle 1 plus angle 2 is equal to what? 180 degree linear pair. Are we clear? Angle D is what? Angle 1 plus angle 2. If angle 1 is 90 degree, definitely angle 2 would be what? 180 minus 90, that is 90 degree. So therefore we got this angle as 90 degree using what? Linear pair. I will write completely for you. Linear pair. What do you mean by linear pair? Two adjacent angles on a straight line. Adjacent angles having same vertices, having one common arm and two non-common arms to be on the either sides. So same thing is happening. Common vertex, common arm, non-common means arms are to the adjacent sides. Clear? Next. Now we can apply the angle sum property in quadrilateral ABCD. Again I can say angle A plus angle B plus angle C plus angle D. Instead of writing angle D complete, I will be writing angle 2 is equal to 360 degree. angle sum property of quadrilateral. Clear? Next, x plus 70 plus 60 plus 90 degree is equal to 360 degree. Clear? This is the outer part. This is the outer part. Clear? I have written that angle D is equal to angle 1 plus angle 2. Clear? Now 60, 130 we will be getting 210, I believe. 130, 220, sorry, 220. X is equal to 360 minus 220. We will be getting 140 degree. This is equal to 140 degree. Any doubt anyone is having with this question? Easy to do, but you need to be very careful. Write like this. Very, very important. This step is very, very important, and you have to mention this how. For the subjective paper, it's very, very important how you attempt. Teacher, as a teacher, we know everything. We can understand if you are writing in the figure 90 degree how you got it. We know it. But in the way, in the subjective paper, you have to represent it. You have to give us that your knowledge. You have to share what you are aware of with your concepts. So do write this. That's very important in the presentation. Next, C part of this question. We'll see the C part of this question. Figure seems to be a bit typical, but it's not. Just observe the figure carefully, then we'll see to it. It's 30 degree. It's X, this is also X. This is 70 degree. This is 60 degree. Let me name it A, B, C, D, E. 5 vertices, it means what is the name of the figure? Absolutely, it's a pentagon. Now observe again, if this is this, I can write this another angle, let me say Y, Z. Clear? So, can I say angle D is equal to 70 plus Y is equal to 180 because linear pair? Definitely. Linear pair, they would form linear pair because they are straight lines. If we see adjacent means this angle, I am talking about this particular angle complete will be making 180. I am not talking about angle C. Do remember, I am talking about basically this I have segregated and this I have segregated to angle this. So this complete angle is 180 and angle D would be Y for sure. Clear? So we can write like this. Clear? Next, if you are getting confused with this, better you can write like 70 degree plus angle D is equal to 180, that's linear pair. If you want, that way also you can write. Clear? So angle D is equal to 180 minus 70 degree. Angle D is equal to 110. Clear? I am talking about this angle if you want. If you are getting confused with that, leave it. Then angle C, 60 degree plus angle C is equal to 180 degree, linear pair. Clear? Now angle C is equal to 180 minus 60 degree. Angle C is equal to 120 degree. Therefore, this is 120 degree. This is 110 degree. In pentagon A, B, C, D, E, angle A plus angle D, B plus angle C plus angle D plus angle E is equal to what? 540 degree. Angle sum property of pentagon. Do remember? Clear? Now angle sum property of a pentagon, if you see, 30 degree X, 120 degree, 110 degree X, 540 degree. Clear? 30, 150, 260, 2x plus 260 degree, 540 degree. So 2x 540 degree minus 260 degree. 2x is equal to, I think, 280 degree. X is equal to 280 degree upon 2. Again, answer is 140. So therefore, this is also 140. This is also 140. Clear? This is how we can do. Same thing you can do in this also. That y angle D 90 degree. If you want, you can write like this. If you want, 90 plus angle D is equal to 180. If you are getting confused, here, leave it that way. We'll keep it very simple. So let it angle 90 degree. Okay, fair enough now. For your simplicity, I have made more clear now. Okay. Next, D part. D part of the same question again. If I name it, though my figure doesn't seem to be same, but assume it as regular pentagon. Assume it as regular pentagon because this shows all sides are equal. All sides are equal means regular pentagon. So in pentagon A, B, C, D, E, angle A plus angle B plus angle C plus angle D plus angle E is 540 degree, not a problem. Each angle is x, 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 x. That is why only one time he mentioned x, because we know that with our concept that this is a regular pentagon, and in regular pentagon all sides and all angles are equal. Therefore x, x, x is equal to 540. Angle sum property of pentagon. Do write the reason, otherwise your marks will be deducted. 5x is equal to 540. X is equal to 540 upon 5. X is equal to 108 degree. So each interior angle of a regular pentagon is 108 degree. If I ask you, then what is the exterior angle? Answer is 72. Each exterior angle of regular pentagon is 72 and interior angle is 108. And exterior angle is 72 degree. Are we clear with this rule? Question number 7, last question of the exercise. Very easy again. You need not to worry about the questions. If your concepts are clear, you need not to worry. At least you need not to. Be thorough with your concepts, I'm telling you. Definitions, formulas, very important. Stick to the definition. What is definition? What is definition saying about this particular term? What definition defines this term? You have to see it and then apply the rules. Simple. Question number 7. I have already given you that sum of all the exterior angles of any polygon is what? Always 360 degree. Now the question is this only. If we see question number 7, A part, we have to find the value of x plus y plus z. This is what the question is. This is 90 degree given. This is 30 degree given. This is y. This is x. And this is z. Okay, clear. Now see yourself, the question is very easy to do. If we see, if we again name it, let it A, B, C, clear. So we can see 90 and 30 are interior angle, x, y, z are exterior angle. Definitely, without even solving, I can write it 360 degree because I have already given you. Sum of all the exterior angles of any polygon is always 360. This is just for the proof. But in the question, if the question comes for 1 mark, then you can write the answer correctly. But if it comes for 2, 3 and so on, you have to explain it. You have to give the proper solution to it. So let's see. First of all, in triangle ABC, I have to find this triangle so that I can find rest of the exterior angles. Therefore, angle A plus angle B plus angle C is 180 degree. Angle sum property of a triangle. 90, we don't know, let it be angle B as it is, that is 30 degree, 180 degree. Angle B is equal to 180 minus 120, angle B is equal to 60 degree. 60 degree. So now just see the point. Can I say 90 degree plus x is equal to 180 degree? Linear pair, this one I am talking. So x is equal to 180 minus 90, that is x is equal to 90 degree. X is equal to 90 degree. Similarly, Z plus 30 is equal to 180 linear pair. Therefore, Z is equal to 130 minus 30. Therefore, Z is equal to 150 degree. So, it is equal to 150 degree. Similarly, Y, if we see 60 degree plus Y is 180 degree linear pair. Again, linear pair because straight line, adjacent angles. Y is equal to 180 minus 60, that is equal to 120 degree. Equal to 120 degree. Now substitute the value x plus y plus z, 90 plus 120 plus 130, 150 is equal to what? 270. 270 plus 90, 360 degree. Hence verified. I told you the answer would be 360 degree. Hence verified also clearly. Any doubt with this question? Same question. Question number B is your homework. B part is your homework. You can do it. You can try again. Answer would be 360 degree. You can see clearly. I am just showing you how to do. Just have a look in the book with this question. When we talk about this question, see 60 degree, 120, 80. If I solve 160 plus 80, 140, 140 plus this is 120. That becomes what? That becomes 260. 360 minus 260, that is 100. So this angle would be 100 by angle sum property. If this is 100, this is 80. If this is 60, this would be 120. If this is 80, this is 100. This is 120, this is 60. 60 plus 100, 160. 160 plus 120, that's 280. 280 plus, sorry. Just see once again. Clear guys, sorry. 120 and 60, 180. It is 60, it is 100. 160 and 120. 160 and 120. What is that? 280. 280 and 80, that is 360. Sum of all the angle is 360. Are we clear with the question? Are we clear with the question? Next, let's do exercise 3.2 also. Let's move on to exercise 3.2. Or we'll continue exercise 3.2 in the next video. Till then, take care and have a wonderful day.